All right, let's make them a little more complicated. So, given a situation like this, and this is going to come up a lot, these kind of problems, if I've got something like sine square minus cosine square is equal to 0, you're thinking, oh man, if it was plus, I would know the answer is just equal to 1, but it's not 1. So I'm thinking, okay, what can I do here? Well, this is when we got to start getting into substitutions. So you'd say, well, wait a second. I could do it like this. I could say, well, cosine square is the same as 1 minus sine square. I could make it all into one variable. That might help clean it up a little bit. So we're doing a substitution. So if I clean this up, minus minus, it's going to become plus. So sine square plus sine square. So I've got 2 sine square minus 1 is equal to 0. Oh, now we can just do a little algebra. So sine square is equal to 1/2. Add 1 to both sides, divide by 2. Oh no, now we have to square root both sides again. Oh man. So if I square root both sides, we've already been through this on the previous video. The square root of 1/2 is root 2 over 2. Well, what do you know? So the answer ends up being plus or minus. So it's all 4 quadrants. All 4 quadrants like that. Okay. But then somebody yells at me and says, no way, man. I would have substituted for the sine square. So let's do it another way, because you know there's always more than one way to work these problems. So what if I had replaced sine square with 1 minus cosine square? Let's see what happens here. So if I do some cleaning, so I would get 1 minus 2 cosine square is equal to 0. So let me see, -2 cosine square, because I got these negatives and I'm more likely to make a mistake with negatives. So if I divide both sides by the negative, negative, oh yeah, so I get cosine equals plus or minus the square root of 2 over 2. Oh yeah, it's the pi over, it's the same thing. So you could have substituted for either one. Now, as we go through these problems and they get more complicated, it's not always going to be quite that simple. Not always going to be quite that simple. All right, let's look at another case that's going to be a big deal, that's going to come up a lot. What about something like this? Whoops. Sine 2x plus sine x equals 0. And then somebody, no, you told us we weren't ever going to have to do the double angle identities. We didn't do them on the previous unit, but now we're going to do the double angles. And then somebody else says, no, but we don't have that memorized. I know you don't have it memorized. We're going to provide them for you. I know you can barely see that, can you? All right, we're going to provide you with the identities. We will always provide you with the identities, the ones on the this is that original identity sheet. So we'll give you these identities so that you'll be able to substitute, plug and chug, et cetera, et cetera. Okay. So in this case, you'd say, oh, sine 2x. Well, that's 2 sine x cosine x. So we have to do a substitution there. Plus sine x equals 0. Now you're thinking, oh man, now I got to do a little algebra. Well, they both have a sine. So I can factor out the sine. And that leaves me 2 cosine plus 1. So then we do the usual routine. So sine x is equal to 0, 2 cosine x plus 1 is equal to 0. So cosine x equals -1/2. So when does sine equal to 0? Well, we've been through that. 0 and pi. When does cosine get the -1/2? Uh-oh. Let me see. Cosine's negative. Second and third quadrant. When does cosine get the 1/2? That's at the pi over 3's. So 2 pi over 3 and 4 pi over 3. A little bit funkier, right? Just a little funkier. Now, here's where it gets really fun. When you've got cosine 2x is equal to cosine x. Now, the problem with cosine 2x is there are 3 different formulas. There are 3 different formulas for cosine 2x. So you're always going to have to choose the one that fits the problem the best. Now, in this particular problem, since you've already got a cosine in it, we're going to choose this one. We're going to choose this substitution for cosine 2x. Choose that substitution because it's already got a cosine. Then We set it equal to 0, just like I keep saying. And now everybody's going to yell at me, oh no, it's a quadratic. So we're going to have to factor it. Unfortunately, that is true. We're going to have to remember how to factor, but we've already talked about that sum. We're just going to have to factor. That's just the way life is. So that'd be -1 + 1. There's going to be a lot of factoring in this unit. Unfortunately, there's going to be a lot of factoring. So let me see, little algebra, subtract 1, divide by 2, cosine x equals -1/2, cosine x equals 1. Well, we've already been through this. When does cosine equal to -1/2? Well, that's 2 pi over 3 and 4 pi over 3. When does cosine equal to +1? Well, that only happens at 0. And if you put 0 and 2 pi, I'd probably be a wimp and count it correct. But that's the way these guys go. Okay, that's the way these guys go. So substitution. These all involved substitution in order to clean the problems up. And we got a little bit more to do. So I'll put it's going to get it's going to get more complicated. I'll put that in another video. So we'll move up. The next video will be slightly more complicated.